Hi everyone, it's Coach Fred here, and today I'm going to be talking about something interesting. I wonder what it could be. I'd like you to take a look at the figures that I have on the page, and I want you to write down on the top of your notes 3 things you notice or wonder about the figures. I'm going to give you a second to do that. They're really interesting, aren't they? What I'm hoping that you saw and you noticed and you wondered was, gosh, they're the same shape, but they seem to be different sizes. Well, maybe except for this one. This is what this whole unit is going to be about. These figures are called similar. They're similar figures. They're not congruent figures. Congruent, as a reminder, congruent figures have the same size and the same shape. So similar are kind of close to that. They're similar to it. Similar, first we use this symbol, just the top part. And although they are the same shape, they are different sizes. They are different sizes. And we say that they are proportional sizes. Their size is in proportion. But everything else is exactly the same. Now this one's an interesting one because congruent figures, we could also say they are similar. They are similar in a really specific ratio that we're going to talk about. And that's what our unit is going to be about. It's going to be about these proportional relationships. So in order to do that, we need to talk about what a proportion is and really what a ratio is. Okay? So we are going to be talking about similar figures, specifically a lot of similar triangles. All right, so let's talk about what a ratio and a proportion are. So what ways can you compare two quantities? Well, you can compare them, you learned this in earlier grades, with a ratio, okay? And if you have two equal ratios, they make a proportion. So here's some examples how we can compare numbers. According to the US Census, there are approximately 32 people for every 10 families. This information can be expressed as a ratio. What would the ratio be? Is there another way to write it so it means the same thing? So I'd like you to write what you think the ratio would be. All right, so maybe you wrote 32 to 10. That's one way we could write a ratio. We could use a semicolon or a colon. You could write it as a fraction, 32 over 10. So for every 10 families, there's 32 people. You could simplify it and you could write it as 16 over 5. That is exactly the same ratio. For every 5 people, there's 16 families. For every 5 families, there's 16 people. So that's a way to write a ratio. Again, we can write it with colons, we can write it as a fraction, and there are some other ways you could write it. You could use the words 32 to 10 if you wanted to, and that would be comparing them. So I guess that my question would be, is it fair to compare the batting averages of 2 baseball players in every case? When would it not be a good comparison? So we don't always want to compare things, okay? It wouldn't be a good comparison if, say, the first baseball player had been up to bat 1,000 times over his career, whereas you were comparing him to a baseball player who'd only played for 1 season. You might not want to compare batting averages of a 8-year-old baseball player and a 20-year-old baseball player. So you can't always compare things. So let's actually look at the definition of a ratio to help us, okay? So again, a ratio is a way to compare 2 or more quantities. So it compares 2 or more quantities. But the thing about a ratio is that we want them to be in the same unit, okay? So they have to be in the same unit. Otherwise, you can't compare them. So if you have meters and centimeters, you really need to put them into the same units, okay? All right, you can write them as fractions or with colons or with the word 2. But when we're dealing with ratios, there's 2 relationships that you have to remember. You could have a part-to-part relationship or a part-to-whole relationship. And we're going to talk about that in a minute. You learned that probably in 6th in pre-algebra. And we're going to spend some more time on it because it's a really important Really, really important idea, okay? Now, I want to talk about something else that you learned when you learned about ratios, and that's a rate. And it is a rate is a type of ratio, okay? It's a type of ratio, but a ratio has to be in the same units, and rates are usually in different units. And rates usually will have a denominator of 1. And we're going to talk about that as it relates to slope, okay? When you think of rate, I want you to think you learned about unit rate, like $2 per apple. That would be a unit rate. If I said maybe like this, if I was talking about apples and it was, I don't know, $2, 2/3. If I wanted to make that a unit rate, it would be 2/3 over 1. So for every 2/3, let's say that this is cost and this is the number of apples. So for every 1 apple, it would be 2/3, so 66 cents, okay? So that's the difference between a ratio and a rate, okay? All right, so the slope of a line is a ratio. The slope of a line is a ratio, okay? It is the ratio of a vertical change between any 2 points to the horizontal change. So that's why we write it as a fraction. We write change in y over change in x. We know change means subtract, so like y2 minus y1 over x2 minus x1. Okay, so that is a slope. Slopes can be fractions, so they are comparisons. It could be going down 2 in this case and over 40 in this case. That would be our slope. So -2 over 40, which we would simplify to -1 over 20. So that is a ratio. All right, let's look at the difference. If I want to find the slope of the line, again, you're finding a ratio. So if I gave you the points 4, 2, and 6, 5, and I said find the slope, you would do change in y over change in x. So 5 minus 2 over 6 minus 4, giving me 3 over 2. Okay, so for every 3, I'm going up or down. I'm moving 2 to the right or left, depending, okay? Whereas rate of change, I might say something like this. This equation, C equals 25H plus 30, represents a plumber's charge for a recent visit to your house. So the slope you would like to say is 25, but as a rate of change, it would be 25 over 1. 1 would be whatever h is. In this case, we'll say it's hours, and 25 would be the cost. So for every 1 hour, the plumber charges $25. So we might write that as $25 an hour. And that is a rate of change. Okay? All right, I'm going to pause here and we're going to come back and you're going to watch video number 2. Have a great night.